Hello students. Hello and welcome to this video. In this video, we will solve question number 171 to 180 of binomial theorems. The link to download the PDF will be in description. At the end, I will show you how we can download the updated PDF from the website and maintain it. And I will also show you my question answer website, which I have created for you, because YouTube is not really a place where you can ask mathematical questions. The comment box just doesn't want to show mathematical content. So without further ado, let's get started. Question 171 says, find the consecutive terms in the expansion of 3 plus 2x to the power 7 whose coefficients are equal. So we consider r plus 1x term, which is coefficient would be there is some certain mistake. It would be 7CR and then 3 to the power 7 minus R and 2 to the power R. So there's a huge typing mistake here. So coefficient of R plus 2x term would be 7CR plus 1, 3 to the power 6 minus R, 2 to the power R plus 1. So you equate the coefficient and you will get R is equal to 3. So fourth and fifth terms have equal quotient. I'll fix this. This is a massive typing mistake. Okay. So now we move on to question 172. Find the sum of coefficients in the expansion of 1 plus 5x squared minus 7x cubed to the power 2000. So we get the coefficients be a0, a1, a2 up to a 6000, x to the power 6000. There should be x to the power 6000. Again, a typing mistake. We put x is equal to minus 1, we get a0 plus a1 plus a2 plus up to a6000. This should be plus 1, not minus 1. It is plus 1. So we get 1 plus 5 minus 7 to the power 2000, which is equal to 1. So two massive typing mistakes. One is here, another is here. Okay. Question 173 says that if the sum of the binomial quotient in the expansion of 3 to the power minus x upon 4 plus 3 to the power 5x upon 4 whole to the power n is 64, and the term with greatest quotient exceeds the third term by n minus 1, and greatest integer function on apply to alpha is x, or rather the integral part is alpha, find the value of alpha. So we substitute 1 plus 1 here, okay? We get whole 2 to the power n is equal to 64, that is n is equal to 6. We have put 3 to the power minus x upon 4 and 3 to the power 5x upon 4 is equal to 1. Here middle term will be greatest term, which is the fourth term. So n is equal to 6, number of terms will be 7, fourth term will be greater. This will be equal to n minus 1 plus t3, that is 5 plus t3. Now we equate the fourth term and 5 plus t3. So we have this expression here, which we solve. We get the quadratic equation 20y squared minus 15y minus 5 is equal to 0, where y is equal to 3 to the power 3x upon 2. So this is equivalent to 4y squared minus 3y minus 1 is equal to 0. So y is equal to 1 and minus 1 by 4, but y will be greater than 0. So y is equal to 1, so that means x is equal to 0 and alpha will lie between 0 and 1 from this expression. Question 174 says that find the sum of coefficients in the expansion of 5p minus 4q to the power n, where n is in the set of positive integers. So we let the coefficients be a0, a1, a2, and an. We substitute p is equal to 1, q is equal to 1. We get a0 plus a1 plus a2 up to an is equal to 5 minus 4 to the power n is equal to 1. Question 175 says that find the sum of coefficients in the expansion of the polynomial 1 minus 3x plus x cubed to the power 201 times 1 plus 5x minus 5x squared whole to the power 503. So we put x is equal to 1. Sorry, this is 175. So we let this is equal to a0 plus a1x plus a2x square and so on up to 80,000 112 x to the power 3520. So here the power would be, when you raise 2 to the power 500, that would be 1006. This would be 1006 from here and 600 from here. So this power seems to be wrong here, because 3 to the power 201 will be 603. So this is definitely wrong. It doesn't matter what is the last term. Anyway, we put x is equal to 1. So this becomes minus 1 to the power 201. That is a negative number, and we put 1 over here, so it becomes 1. So positive to the power 503. So this is minus 1. I'll fix this. This is incorrect. X will never reach the power of 3520, because the highest power over here is 1006, and here it is 603. So it would be 1609. That would be the maximum power. So we have mistakes in 175, 172, 171. Okay. Now we move on to question 176. If the sum of coefficients in the expansion of tx square minus 2x plus 1 to the power n is equal to the sum of coefficients in the expansion of x minus ky to the power n, where n is in the set of natural numbers, then find the value of t. So we put x is equal to 1 in this, we get the sum of coefficients as t minus 1 to the power n. And we put x is equal to 1, y is equal to 1 in this, we get sum of coefficients as 1 minus t to the power n. Now given that sum of coefficients is equal to so we can write t minus 1 to the power n equal to minus 1 to the power n, t minus 1 to the power n. So here n would be an even number. Now, hang on, considering n to be odd. Yeah, so n is even. So this is possible. Wait, consider n to be odd, then minus 1 to the power n is equal to minus 1. So there is no way these will be equal if t minus 1 is not 0. So the only possible value of t minus 1 to the power n is equal to 0, which gives t is equal to 1. Similarly, if n is even, then t minus 1 to the power n is equal to 1 minus t to the power n for all values of n. So we have split the problem in two parts, one when n is even, another when n is odd. Question 177 says that if a0 plus a1 plus a2 up to an be the successive coefficients of 1 plus x to the power n, so that a0 minus a2 plus a4 and so on whole square plus a1 minus a3 plus a5 minus and so on whole square is equal to a0 plus a1 plus up to an is equal to 2 to the power n. We put x is equal to 1, we get a0 plus a1 plus a2 plus a3 up to an is equal to 2 to the power n. We put x is equal to I, we get 1 plus I to the power n is equal to a0 plus a1i minus a2 minus a3i and so on up to an in. We take modulus and then square. We get 2 to the power n is equal to a0 minus a2 plus a4 and so on squared plus a1 minus a3 plus a5 minus so on whole square, and hence we have proven this. Question 178 says that find the greatest term in the expansion of square root of 3 times 1 plus 1 upon square root of 3 to the power 20. We let Rx term to be the greatest term, which is given by Tr is equal to square root of 3, 23r minus 1, 1 minus root 3 over to the power r minus 1. Okay. Similarly, Tr plus 1 is square root of 3, 20cr, 1 minus root 3 to the power r. Now it is greatest term, so Tr upon Tr plus 1 will be greater than equal to 1. So r upon 21 minus r times square root 3 will be greater than equal to 1. So root 3r will be, there is backslash missing, greater than equal to 21 minus r, so r is roughly 7.69. Similarly, t upon Tr minus 1 will be greater than equal to, so r will be less than equal to 8.5. So the only integer between these limits is 8. Hence, T8 is equal to 25,840 upon 9 is the greatest term. Question 179 says that in the expansion of x plus a to the power 15, if the 11th term is the geometric mean of 8th and 12th term, which term in the expansion is the greatest? So we let Tr represent the rth term of the expansion. So 11th term is 15c10 x to the power 5 a to the power 10. 8th term is 15c7 x to the power 8 a to the power 7, and 12th term is 15C11 x to the power 4 a to the power 11. Given that T11 is the geometric mean, so we square the T11 equal to product of 8th and 12th term. So do this and solving, we get x upon a is equal to square root of 77 upon 75. Now PR is the greatest term, so PR upon PR plus 1 is equal to R upon 16 minus R into x upon a is greater than or equal to 1. So R will be greater than or equal to 7.947, that is R is equal to 8, which is calculated here. Question 180 says that this should be capital. If the greatest term in the expansion of 1 plus x to the power 2n has the greatest quotient, if and only if x is in the set of 10 upon 11, 11 upon 10, and the fourth term in the expansion of kx plus 1 upon x to the power m is m by 4, then find the value of mk. So Tn plus 1 is 2ncn x to the power n. Okay. And Tn plus 2 is equal to 2n n plus 1 x to the power n plus 1. And Tn is 2ncn minus 1 x to the power n minus 1. Tn plus 1 upon Tn plus 2 is n plus 1 upon x into 1 upon x. And that is it. I don't know what this is. This shouldn't be there. Okay. Since Tn plus 1 is this could be Tn plus 1 upon Tn. It should be Tn plus 1 upon Tn. That would be that. No. We'll have to verify this. Since Tn plus 4 looks like this is Tn plus 1 upon Tn. Yep. So it should be here, and factorial would be T1 upon n factorial and factorial. This would be n minus 1 and plus 1. So Tn, if it's in the denominator, n minus 1 and n plus 1 will go up, and n factorial will be there, so n will be there. Yep. This is Tn plus 1 upon Tn. Okay. Since Tn plus 1 is the only greatest term possible here, Tn plus 1 upon Tn plus 2 greater than or equal, that is x is less than n plus 1 upon n. And similarly, Tn plus 1 upon Tn greater than 1, that is x is greater than n upon n plus 1. Now this set gives us 10 upon 11, 11 upon 10, and that n is equal to 10. Now we compute T4, so T4 is n upon 4 in this expansion, that is 5 upon 2, because we put n is equal to 10, and that is equal to mc3 kh to the power m minus 3. And we solve, we find that the term is independent of x, so m is equal to 6, which implies that 6c3k cubed is equal to 5 upon 2, k is equal to half, so m2 is equal to 3. So with this, we come to the end of set 180. Now this set question of set up to 180. Now I'll show you my website Ashtavakra. Here you can download Algebra, Trigonometry and Coordinate Geometry PDF, and the dates mentioned are the last upload date. When you will download, this date won't be there, so you need to add date manually. And after 15 or 30 days, you should come back and check if the dates have changed. And if the dates have changed, you should download again and update new date. Also, Coordinate Geometry book is available in HTML format. I would recommend Firefox browser to read the HTML file. So I'm right now working on conic sections, and I expect it to be complete soon. So you can read up to circles, pair of straight lines and locus along with coordinates. Also, if you want to ask questions to me, you can click the 8th link and come to kondika.ashtavak.org. Here we have tags for mathematics, algebra, calculus, geometry, coordinate geometry, probability, trigonometry, and if these tags do not fit your question, then put in mathematics for your tag. You'll need a login, so create a login and ask questions or answer questions asked by others. So with this, I will end this video here, and we will meet again tomorrow with 10 more problems. So till then, I will take my leave, and I wish you best of luck in your studies and exams. Have a great day. Stay curious, keep learning, and most importantly, enjoy.